This conference feels like a blessing and a curse. My presentation was ready a few days ago, but due to the conversations and all that chat, I got inspired and I was changing everything this morning. So yeah, don't do presentation at Gradle Summit. I mean, do it, but first thing on the morning on the first day. That's the best way. I'll start with advice. So be nice to software products on your blog. In 2011, Gradle was tiny. I was a part of that team, 4 people, including Hans, Adam, that was me. And what happened is one day, I was the Gradle consultant for LinkedIn. Hans calls me and, hey, Szczepan, LinkedIn folks found something on your blog. You wrote something like, LinkedIn is quite useless. Like several years ago, what I've done is I evaluated LinkedIn. Clearly, I didn't like it. So I wrote that on my blog. It's actually worse. I wrote it on my about page. So everybody who wanted to know who is Szczepan is this guy. He doesn't like LinkedIn. And then several years later, he's consulting for LinkedIn. So be nice. You might be consulting for those software products, or even, join that team in the process. So I guess it turned out well for me. About 2.5 years ago, I joined LinkedIn, and thank you for having me. This presentation is lessons learned from scaling engineering productivity through Gradle. That's the key, one of the foundation tools that my team, Development Tools, provides to LinkedIn engineers, and I want to tell you how we do it, how we did that. I'm Szczepan Faber. I'm originally from Poland, currently in California, living the dream. It's awesome. And you might be using Mokiro, and I'm sure you have used Gradle, at least 2.x, or one of those. I'm a tech lead at LinkedIn Development Tools. My team is responsible for creating familiar tools across all the technology stacks. It's very important at LinkedIn. It's a part of our engineering culture, because no matter, there's always the same consistent way of identifying the project and code base, getting that code base, working with that code base, submitting your code change for review, and we're basically participating in that ecosystem of software. That is super important. We never want to have an excuse that somebody would say that, hey, I don't want to contribute code to the other team because I don't know how to get their code, I don't know how to work with that code, how do I submit code for review? This has to be sorted out, and it is sorted out at LinkedIn. And my team frequently gets contributions, and those are not pull requests, but to some degree you can associate them with pull requests to my team, and I'm always very appreciative. Somebody else commits his time to help with our projects. Awesome. It also, this ecosystem at LinkedIn feels almost like open source ecosystem around GitHub, where there's a paved path how to contribute to other teams. What would you do? You would get the source code, from where, from GitHub, you would submit a pull request. So it's something like that, but at LinkedIn it's different. We don't use GitHub at LinkedIn. We also, our workflow is not coupled in any way with Git or with source control system. So, more about my team. We are about 30, and total tools, right now we are called foundation team at LinkedIn. We're about 300, and total in engineering is 3,000. So we're big, we are at scale. That's why all the small problems become really big problems at scale, as it happens. And it's amazing for us because this is really nice engineering exercise to scale that productivity and to make sure that software engineering at LinkedIn is a well-oiled machinery. My team is hiring, and it's quite awesome team. I can attest because I work there, so I know. Let's get started with the year of 2011, the time when Gradle was introduced to LinkedIn. We had monolithic code base in the past. We didn't have very good experiences with that. The problem was that releases were stressful and expensive. They were slow. The release cadence was slow. We had release parties, but they were stressful. They were not really parties. We had to change that. Development was slow. This was really hurting the business. And that's the worst that can happen. Your engineering practices and workflows and tools that you use, when they impact the business, when you can't release, you can't do things that you have to in order to have competitive advantage and make business, that's bad. You got to change that. And what we have also discovered is that we had that monolithic code base, like all stuff was there, all the services, and we were trying to scale it, figure it out how to work it. But it was looking, I was basically grinding, and scaling it didn't really like help. There was no like light at the end of the tunnel. It was basically like getting worse and worse. And we had to use like workarounds to be productive. It was not really solutions. I'm going to give you an example. Like in 2011, that one of those big repos at that monolithic code base that we had, you couldn't open that in IntelliJ. You just couldn't, because IntelliJ would not scale for this. But you could work with it in Eclipse. So our workaround was to use Eclipse instead of IntelliJ. But that's clearly not how we want to do it, like, because like, we don't want workarounds. We want to like, maximize the productivity. We don't want to tell, well, it doesn't scale for this IDE, so use another IDE. And maybe it doesn't scale for Eclipse at some point. Well, you can use text editor, right? It's all good. So we can't allow this, and we had to like, change things. What happens is we rolled out a project called Inversion. This was to change how things are. We wanted to make sure that software development process had, like, we have consistency and quality throughout the throughout development process, like across the board in the entire organization. This was the time when Gradle was brought into LinkedIn, and during that time we developed many tools, not only the tools that are related to Gradle, but I wanted to make it important that Gradle was there, and also Gradle is important to help us tackle challenges when we move from monolithic code base into not monolithic code base, but I'll tell more about it soon. The old mono repo was built with Ant, and yeah, let's not talk about Ant. There's nothing interesting about Ant. We chose Gradle. We believe it was flexible. There were certain interesting features, parallel, like incremental builds. But also Gradle had a lot of potential. When we talked with Gradle folks, actually I say we, at that time I was a part of Gradle core team, not LinkedIn, so like I'm mixing we with like Gradle and LinkedIn. It's actually quite interesting because that story, like 6 years of Gradle at LinkedIn, for me is first 3 years I was a part of Gradle core team, and the next 3 years, almost 3 now, a part of LinkedIn team. So like I can see like everything from 2 sides. Gradle. Now, what we believed was key was dependency management that came with Gradle. We saw a great potential there. We believe that dependency management is key when we go off the monolithic code base and we need to manage the software components at scale. Then there was an adoption spike when Gradle 1.0 was released. And this is a big lesson learned, mainly for the Gradle team, I think, but it's also like important for us to understand like how, like the mechanics of that. There were like 2 major adoption spikes so far with Gradle. First was one with Gradle 1.0. The second one when Android community decided to use Gradle, like Google decided to use Gradle as a build system for Android. So those were the 2 amazing things that happened. Now, with this 1.0, I want to tell you this story. Like, you should release 1.0 soon, like early. Don't wait. We waited like I think 1.5 years. Like the 1.0 milestone one, between milestone 1 of 1.0 and 1.0 final, there was literally like I think 1.5 years or something like that. That's crazy. Every month when we met with the team, Gradle team, the list of the must-haves for 1.0 was bigger. It's like, I don't know how it's possible, but it was getting bigger. Like in that model, we would never release 1.0 ever. And it's super important for adoption because people associate like 1.0 with quality, with production ready. It's just this number is magical. Like if you don't get to that number, like it doesn't make sense. Like if you are like participating in some open source enterprise and you want to, don't wait too long for 1.0 because you're losing adoption that could drive you, that could help you build better product. So this happened because within Gradle team we had those self-imposed constraints, like we have to make the daemon stable for all platforms, like for everything. We have to do this, we have to do that. You don't have to, no, like you choose. You can do 1.0 early. And the way I like to think about it is that prefer momentum over perfection. And I don't like perfection, no, not at all. My favorite book that talks about it, and I like how how Peter Bergman models that, is that go incrementally and think about like every single incremental step that is imperfect step, like gives you a glimpse of perfection that is somewhere else. Like go slowly, go incrementally. I mean, don't go slowly, go incrementally. So let's move on. This is something very interesting. This is something that I'm super passionate about, mono versus multi. So I have a question. So, okay, LinkedIn has bad experiences with the monolithic code bases. So make a guess, what are we doing now? Are we doing mono or multi-repo? Mono? Multi. Actually, we don't do neither. Or maybe we do both. It's kind of hard to say. We discovered that this is like wrong model. Like this is not the right way of thinking about it. How your software is like technically or like physically stored and like versioned is really like irrelevant. Like there are other things that are more important. So at LinkedIn, we believe in separate code bases. We find value in having separate code bases, but not necessarily separate repositories. At LinkedIn, an abstraction on top of any software project is a multi-product. It's not a great name, I admit, but like that's the name that we have. So multi-product is some kind of code base. It could be iOS, Java, C++, whatever. And that code base is somewhat separated, decoupled from the underlying source control system. So we have multi-products that you can have at LinkedIn a multi-product, which is a code base that is like some part of like some bigger repository. Or a multi-product that its code base is like a single Git repository. Or a multi-product that has code base and some of that and some configs are in SVN, but most of the Java code would be in Git repository. So it's abstracted out. And every engineer, like when they want to work with that multi-product, with that code base, they have a consistency. They have this tool, it's called Mint at LinkedIn, that they can check out that code base and work with that code base. So we wanted to abstract out from the underlying version control system, and that we found this strategy very, very useful at LinkedIn. The move from SVN to Git was like easy at LinkedIn because we had that abstraction. And it's going to be also easy for us in the future where something else than Git comes along, like you never know. And like organizations have to scramble. And like how can we make our engineers work with this new source control system where all our tools are coupled with that, right? So those kind of problems. And yeah, so instead of mono versus multi, I want to propose a different way of modeling that. And I'm still trying to figure it out, what's the best way. This is the thing that I was thinking most this morning after discussing those with especially with Mike from Netflix and some other guys at the conference. That it's not about how you store your software, like whether this is Git, SVN, big giant repo, like many repos. It's about how you manage your software components. And it can be like a monolith with like central government or federation. So you have autonomy of those software components, but within some ecosystem that has certain bounds and requirements. So let's take a look at the monolith. All software components are like basically built from head, tested and published at the same time. Think about it as that one big deployable or release unit. There's no versioning between internal components. Like no such thing exists. You don't have to do it because you build from head, from scratch. And you have unified versions of external dependencies. So like there's only one version of JUnit used in the entire repository, or one version of Guava used like everywhere in the entire, for all the software components. And this model is typical for, like, let's say, semi-small open source Java project that is a Gradle multi-project build with a bunch of jars. It's like a small, like, centralized release unit. I wouldn't call it monolith because it's, oops, let me fix that quickly. Okay, I promise not to use my hands again. So those are the traits, the typical traits of this style of managing software components. Let's take a look at the other approach, which is federation. Each software component has its own release cadence. We have individual versioning, so they can have different versions. And there is freedom to choose the versions of the external dependencies or even internal dependencies. That freedom comes with certain, caveats. You as a, let's say, owner of some library, if you just depend on everything in the world, including some like unstable libraries that frequently change versions, introduce incompatible changes, you are becoming a liability to your consumers, right? Because they inherit your dependency graph transitively. So it's not like complete freedom, but still there is some freedom to that can be used and leveraged. And with this distinction between this monolith and federation, I don't yet go to pros and cons. So basically all I said was more like the traits, the features of those systems, but I consider all of them, even for the monolith, useful. It's kind of nice if you build everything from head. It makes certain things easy. And it's kind of nice that I can individually version my software components. So all those things are good. Now, how do we make sense of it? Like, what's the best approach? How do we move forward? So it feels that versioning might be the key differentiator between like monolithic approach and federated approach, because the fact that you individually version those software components feels like the most important thing. And in this case, think about this simple dependency graph, A, B, and C. In the monolithic approach, no problem, no versions. When they are versioned individually, we might have a problem. Like that. There's a version conflict. What is the version that should be used? If we are the authors of the software components D, we have a version conflict that we need to figure out. We don't know if our stuff works anymore. So let's actually look at the pros and cons of individual versioning. Stuff that is really good is that we can have incremental and gradual rollouts. I have a new version of a library. Like, I don't have to like upgrade it everywhere across my entire organization. That might have an extremely big cost. I can go incrementally and gradually. This makes my organization nimble. Like, we can like rapidly prototype. We can do interesting things. It adds flexibility. It makes rolling out certain conscious incompatible changes easier. We can say, hey, we need to break compatibility because the previous behavior was bad, or because the APIs did not make sense. And for the new use cases, we would have to keep the old API. It would be very cost prohibitive. So we have to basically break the compatibility. And if we choose to do that, we can roll out a new major version, be consistent, use semantic versioning to tell our consumers that this is new major version, things might break. No, this is the migration guide, this is stuff that you need to do, but we don't have to like upgrade everybody. In the monolithic approach, you would have to upgrade everybody. And this is additional cost that you have to take right now when you do that change. And it's problematic because it prevents you from doing those changes. Like, think about it. I need to make a change that will cause extreme like pain to roll out. Look, I'm not doing that change. I'm moving on. I'm going to do different things. And finally, one of the fundamental pros is that I have some autonomy to choose the versions of dependencies I want to use. So as someone who consumes versions, I can use, I will use the example of a test dependency JUnit. Not sure if this is a great example because in theory, even within the monolith, you could allow to use a different version of JUnit. But typically in monolith, you would have a single version of given dependency. So let's consider JUnit. Like in federated software components and at LinkedIn, every multi-product, every code base can use whatever version of JUnit, and nobody is bothered. It doesn't really matter. It's fine for the ecosystem. It doesn't really introduce any problems. And it's nice because some teams can go faster. They can adopt JUnit 5 right now, today. They don't have to wait for everybody else to do that. There are, of course, cons, and those are serious, like version conflicts at scale, where like stuff breaks, and sometimes in production when tests are inadequate, those are like serious conflicts, and it hurts developer productivity. The bigger your dependency graph, the more problems you can expose. And when you start bumping versions, you discover that, okay, today I was not really writing any code. I was, trying to figure out the dependency issues. So that can happen. There may be too many versions in use because if I'm a producer of some library and I'm producing frequent versions of that library, who knows whether those versions are in use? Maybe like people don't use my new versions and they basically staying on like old versions. And some team, hey, they want to use some library that comes from my team, but with what versions should we use? You publish like 5,000 versions, like which one is the best? Of course, the latest version is always the best. And stale versions in use. Those stale versions are your tech debt, essentially, because they might have security vulnerabilities, they might have problems, like we would have to manage that. So with individual versioning, we have pros and cons. I believe that this autonomy within ecosystem is key because it makes us go faster. It increases the velocity of teams to evolve the software faster. So I think that's key. And I can tell you how we managed some of the problems, like version conflicts at LinkedIn with Gradle. So finally, Gradle comes to the picture. You were waiting for that. It's Gradle Summit, right? So how does Gradle help in all that? It's helping us with its excellent APIs for managing dependencies, from conflict resolution, dependency validation, dependency rules, and composite builds. Let's talk about multi-product versioning. Multi-product is, you can say it's a code base at LinkedIn. And what we do is that all the software components that are published from that multi-product, they would have the same version and they would have the same group ID coordinate. At LinkedIn, we use IV model for our dependencies, but you could use POM. POM also has a group ID. And the fact that we have that consistent group ID per multi-product helps us. We can do interesting things when it comes to dependency validation and those kind of things. So let me tell you what happens. Let's take a look at that dependency graph. It's easy, but let's spice it up a little bit. What if component C depends on library 2.0? And what I wanted to point out there is that B is code base, it's a multi-product, but B impl is one of the libraries or software components produced from that multi-product, produced from that code base. So what happens now when B library imports B API at different version? It's a very interesting case because what Gradle would do by default in this case is that Gradle would pick up version 2.0 because, well, this is the higher version, so it's a higher chance of succeeding. Maybe it's compatible, so maybe it's all good. What Maven would do, Maven would use 1.5 because Maven uses this nearest algorithm and whatever is declared in the POM file of the software component A would be used, which means version 1.5. But either way we go, whether we choose version 2.0 or whether we choose version 1.5, most likely this breaks. This dependency graph is just broken. Why? Because provided that the authors and maintainers of B software component honor semantic versioning, they probably introduced incompatible changes between versions 1 and version 2. That's the reason they introduced a next major version. So like something will not work here. Like the impl component will not work with the B API 2.0. Likewise, the library component will not work with the B API 1.0 if this is the Maven case and B API is downgraded to 1.5 following the default dependency resolution of Maven. So what happens at LinkedIn is complete. It's actually something different. So at LinkedIn, every multi-product has a product spec.json file that has a bunch of metadata about that product, including the dependencies. It's a JSON file, and we declare external dependencies and also LinkedIn dependencies there. We declare only first-level dependencies. We don't declare their transitive dependencies. What happens is that we created this concept of consistent versioning. So whatever is the version that is in the product spec will essentially win during the conflict resolution. That's the version that is used. It gives us, to a large degree, like a source of truth for dependencies in product spec.json. It's also interesting that the versions of dependencies are outside of the Gradle scripts, because this allows us to have this layer of integration, like certain tools can change the versions in the product spec file or read the product spec file and things will work, right? They are like, the tools can operate at a different layer. They don't have to modify the build or Gradle files. We also do an interesting thing, which is downgrade validation. And basically, we detect the situation on the previous slide, and we would fail the build in that case. Let me actually explain it a little bit more. So at LinkedIn, this, like if you are building software component A, we would immediately fail. Why? Because at LinkedIn, we believe that in the product spec of multi-product A, you have declared that you need the B component at version 1.5. But transitively, you are pulling in higher major version than the one that you want to use. And most likely, it's going to introduce breaking changes. At LinkedIn, we want to apply the semantic versioning, and we want our tools to embrace semantic versioning, and also our teams to use semantic versioning. So at LinkedIn, this would fail, saying, hey, like, do you have a problem in your dependency graph? You're downgrading one of your transitive dependencies. It's going to introduce the problem. How to fix it? Go and upgrade the version of your B component in your product spec file to 2.0. There's a question. I can take it. I think I have time.
Does this assume that external dependencies also follow semantic version truthfully?
It does, however, it does. There's no however. It does.
Okay.
It does, but like it has caveats. I totally agree with you. And also, this model technically can work only for LinkedIn in like internal software components, because at LinkedIn we have that convention that every group ID of the software component released from like other multi-product has the same group ID. Hope it makes sense. For external dependency, we can't guarantee that. So that's why, like, note that this, like all those four like blue components here, they're coming from the same code base, from the same multi-product, but those are different, let's say, modules, different jars in the Java land, API library, and impl. So with transitive dependencies, you not necessarily have a chance to like operate on that level. And yeah, so this model is nice, but it doesn't solve all the problems. Like it's like we've added a layer of validation and constraints on how dependency is managed at LinkedIn. It doesn't solve all the problems. Like with the complicated dependency graph, and in the real world, if you look at the applications that are essentially consumers of all the dependencies, they have humongous dependency graphs, and like, you know, version and upgrading versions there are sometimes is a pain. But for that, we also have tools at LinkedIn. You run a little tool and it's going to upgrade versions that are needed to be upgraded for you. You don't have to kind of chase around which versions that you want to upgrade. We use dependency rules to implement some of that capability. And I want to show you an interesting dependency replacement rule that we have. We can introduce some patches to how dependency resolution works at LinkedIn, like at global scale, and like avoid certain bad dependencies using the dependency rules. It's similar to some of the plugins that are available in the open source, like Nebula plugins. They also offer similar capabilities. But those are nice Gradle APIs. So let's step back a little bit from dependency management. Cross-code-based refactoring is also something very interesting that is effectively brought to us thanks to Gradle. This is the feature that LinkedIn sponsored in Gradle open source and has been, it's still in development, but it's like, I think by July it should be like finished for like all the use cases like parallel builds, continuous build, and everything. And why cross-code-based refactoring is so important? Because when we moved from the monolithic code base into these federated software components, into multi-products, we acknowledge the need that sometimes, in order to make changes to that system, that change spans many multi-products. So we have this initiative at LinkedIn called cross-product development that aims to address that and add various tools to the development workflow to make like working across like many like code bases convenient and easy. This is one of those tools, cross-codebase refactoring, which is given to you by the combination of the composite builds and IntelliJ. And by now, IntelliJ comes with the support for composite builds. Before IntelliJ, this year, IntelliJ got that feature, but at LinkedIn, we have developed that last year. We had, at LinkedIn, we also have IntelliJ plugin that makes basically IntelliJ smart about LinkedIn. IntelliJ knows about LinkedIn's development workflows and makes developers productive. And we combine that. So for example, when you check out a multi-product from IntelliJ, what happens, you can choose like other code bases, other multi-products, and bring them over to IntelliJ, and then you can do refactorings across the code base, which is nice, which is what we want. Now, there are caveats to that. Like if you do your refactor and perform it, the next step is that you need to check that in, right? But the change is spread across multiple repositories. So there are problems like how to atomically like commit that. And you don't have to commit that atomically in our model because it's about versions. So like first one version is released and then the next version. So there is an interesting engineering challenge to like automate that process and making those changes like easy for LinkedIn engineers. And some of that tools are still like at work, which is nice. Like development tools at LinkedIn, we never stop. We just relentlessly and continually create more tools. Actually, that doesn't sound good. We should not be creating more tools. We should be creating less tools, just solving the use cases, right? All right. Finally, we are in the year of 2017. Now, like almost every project uses Gradle, which is amazing, because back in 2011, like we didn't know that Gradle is a thing. It's like Gradle was at version 0.7 or 8. It was, we used it for Java libraries or wars, like very like small usage. Bunch of code base was still built with Ant, and some of the code was built with like certain Python tools. So Gradle was only used for like a small set of tools at LinkedIn. But what happens is like throughout those 6 years, Gradle basically was consuming and covering all the ground. And even this year, we've finally pushed Play framework applications to production with Gradle, which is amazing, which was like our last gap. Python also was implemented. We added support to Python language, which was amazing because this adds like a proper dependency management to the ecosystem of Python tools, which was like very innovative. So we found Gradle very useful, and what I want to share is that we used Gradle because it was just it was a damn good tool. It was really doing well in what it does. The dependency management was awesome, and we loved the fact that we could scale that Gradle infrastructure, our core LinkedIn Gradle plugins, we could like reuse them across those different technology stacks. So like our dependency rules are applied to like Java project, but also to Python projects and other kinds of projects because of that strength of leveraging the same technology for different technology stacks. And it was also important for Play on Gradle, which is, we had the presentation of that yesterday. Play framework, traditionally built with the simple build tool, SBT. You can now use it with Gradle. And it was extremely it was such a difficult project, but we figured it out. We made it happen, and the feedback from moving like Play developers to Gradle was amazing. Like people were saying like this is like 3 times faster. Thank you guys. And Play was essentially like our last stronghold of some like other build tool, not Gradle, and now we're like fully Gradle. It's like awesome. It's a good feeling, especially as. Again, like we did it because that was the best thing to do. We didn't do it just for the sake of, let's just use Gradle for everybody. We chose Gradle because it was the best tool to do that job. And yeah, I tell that already. I'm moving on. So Gradle Platform at LinkedIn, we also acknowledge the need for other teams at LinkedIn to develop their own Gradle plugins. And even our own core plugins started growing since 2011. There were like more and more and more. Hey, let's add Scala support, let's add Hadoop support, let's support this and that. And at some point, we have this little monolith of Gradle plugins, like one multi-product with all Gradle plugins. And this was having all the issues of monoliths. Like, I want to just change, I want to introduce this little change to the Scala library. But then you have to release all those plugins, right? Because you release them on at the same time. And we decided to split it, so we broke down our plugins into like separate code bases. And in that process, we've developed this layer of API. So at LinkedIn, if some team has an automation need, they can create a new multi-product of type Gradle. It will be a Gradle plugin type of multi-product. And he has an engineer would have convenient mechanisms for developing that Gradle plugin, and also for publishing and rolling it out to the organization, to whoever needs to use it, whatever team needs to use it. Finally, we have other dependency engineering tools at LinkedIn. I want to briefly mention them. Not every tool is like coupled with Gradle or leverages Gradle. Some of them are pretty much different tools, not leveraging Gradle. What we do is we do downstream dependency testing, which there's a new name coined yesterday for that as well, publisher feedback, if you saw all the keynotes. What it means is that if you have a change to your software, to your multi-product, and you propagate that change, the change is reviewed and you ship that change, what's happening is our continuous integration pipeline would automatically rebuild all the other like software projects at LinkedIn that depend on your change, on your project. And that's automatic. And if one of your dependers fails for some reason, this signal is fed back to the continuous integration machinery, and your build is red. Your build is not accepted. And this means various things. Some teams configure the behavior to be like, roll back my change immediately, like revert it from the source control. Some teams would say, okay, just leave it, we're going to fix it. It really depends on the strategy. But in general, that change will not be published. And I will tell in a second what it means when the change is published. We also attach metadata to our versions at LinkedIn, to the software components at LinkedIn. What it means is that you can say that for that library and that version, this is end of life. Like nobody should be using that version. Okay, let's talk about the use case. You are very happy on Friday, you finish writing this big feature, you ship that change, it went into source control, continuous integration build was happy, version was published and added to Artifactory. On Monday, you figure out, oh, there was a bug there, I don't want anyone to use that version. So what do? At LinkedIn, you would use the version catalog to say that that version should not be used. And then the system will respect that metadata change and would like not allow anyone to build their code with that version of library. We also have wildcard dependency versions. So in the product spec file, you can declare, give me like 1.*, like any version that is compatible with version 1.0. And this is nice because those dynamic versions, they actually respect like LinkedIn's version metadata. It's different than the plus sign in Gradle, because plus sign in Gradle will just get you the latest, but that doesn't work if that latest version contains like a bug and should not be used. So at LinkedIn, it's handled differently. We use wildcard versions that are based off our version metadata catalog. We also have tools for pushing upgrades. So you have a new version of a library, and you want to push it to your downstream consumers. There are tools to do that. And finally, continuous delivery. This is, I believe, my favorite thing. Every change is a release candidate, is a new version of something. This is really in the spirit of continuous delivery, and it's sort of a mind shift. And it's really interesting for both, for library developers and also for like application developers. So let's talk about library developers. It means that if I have a change, I submit that for code review. At LinkedIn, code reviews are mandatory, like every team needs to do code review. So code review each code change has to be approved by somebody else on the team. So you get a code review, you get to ship it from someone who reviewed your code, you check that in. If continuous integration is happy, a new version is published to Artifactory, and from your project, that's the latest, that's the best version for everybody to use. Which is interesting because now every single change, every code submission needs to be high quality. You gotta have tests, you gotta have documentation, you gotta have everything. It has to be compatible, it has to be good. You don't have the luxury of deferring the quality. You gotta have, like, on a daily basis, you have to produce with high quality. And I wished Gradle did that. That would be awesome if Gradle was released all the time and I didn't have to wait sometimes like 4 weeks or 6 weeks for a bug fix or for something. It's very interesting also for application developers. Like, think about LinkedIn.com. So every commit to LinkedIn.com, and LinkedIn.com is like a complicated beast, right? You have front end, you have mid tiers. It's a really complicated system because it's like a huge, massively scalable application. But let's consider only the front end. Every commit to the front end and that passes the CI machinery, like our automated validation, would produce a new version of that application, and that version would be in Artifactory available to use. And now it's up to the team how they configure the automation, whether that version is further propagated through the pipeline and going through the full release pipeline, like canary release and then rollout and then enabling of the features. So LinkedIn.com ships 3 times a day. It doesn't ship on every commit. Just want to make it clear. But it's still a pretty. It was a big mind shift in 2015 when we enabled this mode, and you can read it about it on our LinkedIn engineering blog as well. The initiative that enabled that for our flagship application for LinkedIn.com was called 3x3. 3x3 meaning that maximum time from commit to production should be 3 hours, and we do 3 releases per day. And in that model, there's just no way you can do any manual validation or verification of the code. Everything has to be automated. Moreover, you have to figure out how can you automatically validate your code within 3 hours, because that's the time window that you have. You can't run end-to-end tests that run for 24 hours and just validate every single feature, because you would not that window. So it pushed extreme pressure and stress on like tools team at LinkedIn or like on engineering to figure it out, how we can do it, how we can make it happen, and we made it happen. And now it's becoming part of the culture that like every single change that I do is high quality. It has to stick. It has to work because it goes to production. It can go to production within 1 hour. It's amazing. For open source, check out the shipkit.org project, which me and a couple of guys passionate about continuous delivery are cooking. It's related to how Mockito project for Java is publishing versions for every merged pull request. It's kind of awesome. Finally, partnering with Gradle Inc. was very fruitful for us. Since 2011 to now, it's so nice that at this conference I hear about various features that either we sponsored or we demonstrated use cases and partnered with Gradle, incorporated how to like develop them. It's amazing, like various dependency management stuff, configure on demand, some of the build avoidance. Finally, composite builds, what was the last feature that LinkedIn has sponsored, like good stuff. So if you don't partner with Gradle Inc. yet, do it. It's going to be fun. And I think I might have some time for questions, because that's the end. Any questions? Because I heard the clasping, so yeah, I should finish. No questions? Awesome. Go do continuous delivery and use Gradle and stay happy. Thank you.